Hello guys, my name is Raj and welcome to my channel. So this is a new video in complete placement preparation series, and today we will solve this particular problem which is 74 listed on Leetcode. So this is search in a 2D matrix. So this is a medium category problem, and the submission rate is around 40%, so good enough to discuss. So we have to we will be given a 2D matrix, and we have to search for an item in this particular matrix. So the item may or may not be in the matrix, but there are certain properties of this matrix that we have to keep in mind. So this matrix is sorted. It has sorted rows. So all the rows are sorted in increasing order. So you can see 1, 3, 5, 7, 10, 11, 16, 20, and they are also sorted column wise. Okay. So basically, the last element of the first row is smaller than the first element of the second row. And similarly, how to solve this particular problem? So if we had a simple one dimensional matrix, then what could be the solution for that particular case? So let us I want to search a particular item in a one dimensional matrix. So we can simply do linear search, which is obviously the naive solution, but the best solution could be binary search, right? So in this case, since we have this kinds of property for 2D matrix, we can also incorporate binary search in some sort of way, and we have to incorporate it to get the best solution. Okay, so the naive solution says is to have iterate through each and every variable, each and every element, and check if it is our target element or not. So that is one naive approach, which is of order of n square. So that is always that we have to avoid. So apart from that, how we can proceed and get to know this particular key, how to solve this particular thing. So if you notice that for any element to be in a row, what should be the property? So the property should be, it should either lie, it should lie between the range of the first element and the last element of that row. So if that element is greater than the first element, greater than or equal to the first element, and smaller than or equal to this last element, then we can say that okay, this element might lie in this particular row. Else we don't have to check anything, right? So in this example, in example one, if my search element, if I want to search 15, if I start with first row, I have to simply check and compare if 15 is greater than or equal to 1, so which is true, but is 15 less than or equal to 7, which is not true. So basically 15 will not lie in this particular row, because the highest value in this row is 7, which is smaller than 15. So there is no point iterating to this row, right? We will go to the second row. Similarly, we will check for that as well. So in this particular range, it will lie because it is 10 and 20. So 15 lies in between somewhere. So there is a possibility that 15 might exist in this particular row. So then, since we have narrowed down our search corpus to a single row, now we can search thoroughly in that particular row, that if that element exists or not. So for that we can use binary search. Since we have converted our two-dimensional problem to one-dimensional problem, now we can simply apply binary search and do our task. So this was one such thing. And obviously after shortening the 2D array to 1D, we don't have to proceed further because we already have found our element, right? So this kind of a solution is an optimal one, and it will directly boost up the efficiency in terms of time and space. So let's try to code this particular thing. Also, there are some constraints. So constraint has to be kept in mind. So m is your matrix length, which is number of rows. N is your number of columns. The m and n values will be in the range of 1 to 100. So number of rows and number of columns would be in the range of 1 to 100. So it will not be beyond that. And the individual values in this particular matrix can vary from minus 10 to the power 4 to plus 10 to the power 4. So these are the constraints. So let us try to code this thing. So first of all, we will save the number of rows and number of columns. So length of matrix will give us the number of rows, and n equals to length of matrix of 1, so which will give us the number of columns. Okay, then so this looks good. So now we will iterate through all the rows. So for that I will use m. So m is nothing but the number of rows. Okay, so now I will check if the element lie between does lie in the particular row or not. So what I will do is I will add matrix of m 0 is less than or equal to target. So target is our element to be searched, and matrix dot matrix of m minus 1 we will return the last element of that particular row. It should be greater than or equal to target. So I have I have tried to check if that target lies in this range or not. So if yes, then we have to search, or else we don't have to search. We'll simply go to the next row. So if the element lies in this particular range, then I have to binary search. I have to use binary search to traverse through the row. So for that I will use the start. Start is nothing but 0, and is n minus 1. So here n is the number of columns. So I will use while loop. So while start is less than or equal to n, which is simple binary search logic, and then I will have a mid value. So mid will nothing but will divide the array into half and search if the element lies in either side or not. So start plus end by 2, and if I'll check if target is equals to matrix of I. Oh, oops, I made a small mistake here. It should be I. It should be I. Okay. Okay, then target of mid. So if this is true, then I will return true. So the element lies and we have found the element. If not, then we can check if the particular target value is bigger than the middle value or not. So if it is bigger than the middle value, then we have to search in the second half, and if not, then we have to search in the first half. So that is the simple binary search logic that I'm explaining. If target is greater than matrix of I of mid, then what we'll have to do is we have to increment the middle value. Sorry, not the increment the middle, the starting value, which is mid plus 1. So I'm incrementing the start pointer to the second half. Else I will decrement the end pointer. So this is start, this is end, middle minus 1. Okay, and this is it. So this will end our loop, and at the end, if we don't find the element, then we will simply return false. Okay, so this looks good. So take a quick look. So number of rows, number of columns. We'll iterate through all the rows. I will check if the target lies in the range or not. I will initialize the start and end pointer. Start the binary search logic. Start is less than end. Find the middle value. Compare with the middle value. The comparison is true, then return it. Else compare if the target value is greater than the middle value. So if it is the case, then we will go to the second half. Else we'll remain in the first half. Okay, so this looks fine. Let's try to run this thing. So this is true for this case. Let's try for this case as well. So we are searching for 3 in this particular 2D matrix. Let's see. So this is written true. So let's try to submit this thing. and this is working fine, so it is faster than 65%. So 65% is very good in terms of submission, and since it is accepted, every code is fine. But if you are competing in an interview, then your code should be efficient. And also you can make this code more efficient as well. You can try to use binary search for the row part as well. So here I have used for loop. So for other than for loop, you can use you know going, instead of going from the first row till the row we find, you can directly use binary search for that. So that will be two binary searches going on in a nested form. So that is also that you can try. So it might boost up this particular 65 to 100. So that is something that is homework for you guys. So thank you. I hope you have liked this particular video. If you like my content, please like it, share it, and subscribe my channel. If you have any comments, feedbacks, please write it out in the comment section. Also, you can reach out to my social media handles that are also listed below. So till then, this is Raj signing out.